another physics video. Sorry, but yeah, just for the record, I know this is too much for anybody to endure, but yeah, it's physics girl. Okay, charming enough, blah blah blah. But yeah, if she was a guy, I'd really be ragging on her. So yeah, I'm showing my chauvinism. Yeah, reverse chauvinism or whatever you want to call that. Cut the chick a break. But yeah, no, this is just crap. And so I just thought I'd play it. This is just crap. Just crap.
The first problem introduced by the old Big Bang Theory was called the horizon problem.
Which is basically the problem of trying to understand how the universe got to be so uniform. Why does the universe look the same over there as it does if you look that way?
And why?
Right. Now, this is all based on an idea that I didn't really realize that this is what these people were saying. That somehow the Big Bang doesn't mean like any bang you ever saw in your life. Like any, like if I put a hunk of TNT in space and blow it up, somehow the bang only goes somehow crooked or something. I mean, I can't even come up with an analogy for any banging object that would in any way make any sense out of this. Why would one side of a nuclear bomb be hotter than the other side of the nuclear bomb? What example do I have? Why don't cannonballs fly out of cannons crooked? Because there's somehow more energy on one side than the other. No. Explosions happen, and they happen in this, what I conceived of as the Big Bang would be like in a perfect sphere kind of way. The interior explodes, it creates a pressure wave through the whole thing, and the entire thing crumbles quite evenly. That was my understanding. Star Wars, you know, stuff blows up and it's kind of circular and even. No, I'm not at all confused as why there's just as much explosion on the right as there is explosion on the left. Seems reasonable to me.
Was this the problem? Well, think of a cup of tea. If you pour milk into your tea, it'll...
Now this, as an analogy, the Big Bang is milk going into tea? Huh?
Take some time for the molecules...
That's the Big Bang. The Big Bang goes in as a blob on one side of the cup and then swings around and mixes and does all this mixing thing. It does. It's not a centric explosion. Goes from small to big. Yeah, sorry. So apparently this is some sort of mathematical problem they have in physics where somehow, somewhere the math tells them it all goes crookedy somewhere. I don't even know. I don't know why this is. I can't conceive of how this is possibly even a how does their math go this crooked where they can't conceive that the Big Bang wasn't a crooked explosion? It wasn't milk going into tea. I'm just looking at, how could this possibly be how you would explain an explosion? If I put a piece of lithium, I put something in here and it explodes, it's not going to do this, it's going to do this even thing. It's going to evenly disrupt this cup of tea. A water dropping into a lake, you get a little even crown of stuff coming up. Not complicated.
interact and eventually come to about the same temperature. But it won't happen instantly. The same is true on a large...
Yeah, well, it's not the same as true on a large scale. I just don't... What scale are you talking about? The universe pissed. You know, was pissed. That's not the Big Bang, it's the Big Piss. So the universe was pissed into some empty space, and it took it a while to mix into the empty space.
Larger scale, the fastest...
Well, you probably don't understand that one, because you have to kind of be a man to understand the whole directed pissing thing, but whatever.
Any two objects can interact is as soon as light has had time to travel between them. Well...
Right, so these are all the premises of their argument. That somehow the two sides of the universe needed to interact to become two sides of an even explosion. So somehow Why is this necessary? Why do I have to account for any of it? Why does one side of the universe have to mix with the other side of the universe? Why does any of that have to happen? I don't understand. What does this have to do with something called a Big Bang?
According to conventional Big Bang theory, light hasn't had time to travel from one side of the observable universe to the other.
So, and why did it need to again? If it bangs and shoots everything out, why does it need to do that? And again, even if you think the universe is some sort of like a frisbee, like the universe exploded like a frisbee out, right? I guess that's what they're saying. It isn't a sphere explosion, it's a frisbee explosion, and the frisbee's moving through time, and the frisbee's getting bigger. Still don't know why one side of the frisbee has to talk to the other side of the frisbee. Why do I think it needs to do that? Why would I think there would be more frisbee on one side of the frisbee than the other side of the frisbee? Same frisbee, different side. Why should I think one of my shoes is different than my other shoe? They're made by the same thing. Unacceptable.
So why should they be at the same temperature?
So inflation gets around that in really a very simple way. That
Yeah, really very simple way of getting around the thing that isn't a problem. So yeah, we got around the problem that wasn't a problem by creating a problem.
if we trace back the universe that we're looking at now to what it looked like before inflation.
Right, so this is what they've done to the idea of universe, I guess. So they had to create some sort of time thing, funnily thing, you know, where stuff doesn't go someplace and then we see it where it went by a certain amount of time. I mean, I don't think it's really possible for us to be looking back there. So I don't think anything's back there anymore, right? I mean, as explosions happen, you kind of get the idea that most of the stuff exploding ends up away from the beginning, right? Like after a little while, there's not much left at the place where the explosion was, and there's a whole bunch of stuff in a ring around where the explosion was. Isn't that usually how it works? Not too much in the middle, lots of stuff on the outside. So why would be lots of stuff back here and a little bit of stuff here? Well, I understand the time interval, but I'm still saying even with the time interval, the stuff has to move.
It was vastly smaller than anybody would have thought without the inflationary theory.
Right, so they're just doing some kind of math thing here. So here they draw it as a perfectly symmetrical kind of thing. So I don't know why it's a big deal or a problem. Why would size mean anything to me or you in terms of understanding an explosion? Why would I have to reduce it to a pea? Why can't I make it a basketball? Why can't I make it the size of an elephant? Why can't I make it the size of a frickin' galaxy? The explosion is still going to be from the inside out. The explosion, just like the center of gravity of the Earth explodes. The idea will be it'll explode from the center out. Doesn't matter how big the center is, doesn't matter how big the Earth is. A bunch of little pieces are going to fly away.
Vastly smaller is not an exaggeration. Before inflation, everything in our observable universe fit in a volume a billionth the size of a proton.
Right, so now that's I'm supposed to believe that. The entire universe was shoved into something a billionth the size of a proton. So all the atoms, all we know about real physics, which is, you know, atoms have to be a certain size and there's no matter that can be, you know, you can only compress it so much and then it's not matter anymore, it's something else. So do we have any examples of any kind of matter that can be that dense? No. That it's physically possible to condense matter that much? No. Can we create any machine that can compress a piece of elementary matter that much? Smaller than a billionth of a proton? Basically eradicate all the protons and neutrons and everything and then compress them even more than they're already compressed while they're protons? I mean, I would argue that protons and neutrons are already pretty freaking compressed quanta. I mean, it's an awful lot of little bits inside of there in a tiny, tiny, tiny space. Yet you think you can do 1,000,000,000 times better, and then on top of that, shove the entire universe in that billionth thing that's smaller. And this all makes sense to somebody. Nobody can say, whoa, ouch, what are you shoving up my ass? What the hell was that? Come on.
And the universe went through 2 expansions.
Oh, there we go. And this drawing is just absolutely crap. So the explosion was like, really weak. We're barely getting away from each other. We're barely going anywhere. I imagine this is time. And then we just kind of get lazy. Oh, where's the second expansion? I guess I'm missing it somewhere. Oh, there's supposed to be, this is supposed to go out actually, because now they're saying the universe is going to drivel into nothing. Everything's just going to fly apart, and nothing will ever see each other again. So maybe that's the truth, but I'm just saying they didn't draw it right. Yeah.
Inflation and after. Both expanded.
Inflation and after inflation. Well, isn't that interesting? Sure, makes sense to me, of course. Lots of inflation in the economy. Inflation's just obviously everywhere. Even the universe has inflation.
Space by a factor of 10 to the 28, but the
10 to the 28 factor of inflating stuff. I don't know what that means.
second expansion took 13.8 billion years.
Oh, well, that's what you say, Chicky Poo. Yeah, why? Because that's as far as our telescopes can see, so obviously that's when everything stops. What do you want to bet? That the other telescope that's supposed to be able to see like 15 billion years will see 15 billion years?
That first expansion, inflation, took 10 to the...
Wow, there we go. Okay, so this inflation took... Let me hear this. Let's wait for it.
minus 38 seconds.
Okay, so that's the argument. The argument is that everything flew to this whatever expansion is. I don't know how that is, but it looked like it was half the size of the regular universe. But do you believe that's what happens in explosions? There's just no resistance. The explosion just explodes. Everything flies off in this kind of speed. I don't know, is that faster than the speed of light? It seems like it must be. Yeah, it's some kind of distance, and it's going per second more than the speed of light. So this stuff went there faster than light. So I'm supposed to believe you broke that constant too. Fuck that one too. Yeah, fuck that whole speed of light thing. Fuck that. Doesn't mean anything. We don't need that.
It's just an unfathomable rate.
Yeah, it's just a pile of crap is what it is. You people just made this shit up. You made it up. Yes, you did. You made it up.
Back to you, Goof.
And it was during the time before inflation, when the universe was incredibly tiny, that there was plenty of time for every piece of the universe to communicate with every other piece, and plenty of time for it to come to essentially a uniform.
Right. It did it all in that half of a zillionth of a second, so there was plenty of time for everything just to mix around and say, hey, yeah, let's mix around and do all kinds of fun stuff, and then we'll get around to exploding, or something like that. And this is your definition of how explosions happen. So, big bang. This is what you think happens when something goes bang. The gunpowder doesn't cause a chemical chain reaction that creates a pressure field, and everything just kind of flies away in a direction because of the pressure. That's not banging. No. Banging is... well, everything kind of just mixes around and says, hey, how are you doing? What are you doing? I'm going to go that way. Which way are you going to go? Well, I was thinking of going that way. Well, you really can't do that. It's probabilistic. We need to mix together. So maybe you should go that way and I'll go this way, and that'll even everything out. I hate physics. Physicists.
Uniform density of energy and uniform temperature.
They're doing it again. Why do I need any of that when I'm exploding something?
So now we know the universe was super...
We know it. Now we all know it. Wasn't that explanation full and complete? Isn't that evidence just so compelling? I mean, he sure as hell proved it, right? I mean, god damn, I'm convinced, right? There's nothing extraordinary about this claim, and it shouldn't require something like extraordinary evidence. You don't need any evidence at all. extraordinary claims should just have ludicrous evidence. Let's just draw it. Let's just make space-time so that we have space-time. So let's just make ludicrous explanation. And then we'll just combine ludicrous and explanation, and we'll just bend it, and everything can fall into that void, that crack. Ludicrous explanation. It sounds like a chick thing. Yeah. Vagina? Yeah, it's all the same. She has great, her expressions are so funny. I have a very expressive face. It's a little scary sometimes, but it is kind of, a lot of shit happening there.
Tiny. Well, the true genius of Guth's theory was not the incredible...
It was genius, she says. It's fucking genius. Gosh, you turn everything into the size of a billionth of a proton. It's fucking genius. So obvious. Of course. You have a problem, just crush it until it's the size of a billionth of a proton and your problem goes away, right? When a problem's that small, who the fuck cares?
Tiny universe, but how it could have expanded so fast. Inflation provided the mechanism for expansion.
Right, because nothing had to actually do anything because, again, magic space saves the day. So nothing had to actually move because the space just had to expand. So nothing actually had to do anything. Just make the space do it. It's so simple. It's so obvious. Oh, please, can't you get it? I'm going to do this. What is dark matter next because that has lensing in it. Oh, God. This is such crap. I'm sorry, people. This is crap.
Repulsive gravity.
There we go. Repulsive gravity. Now we've really got something, don't we? Now we're really getting to the core of it. So all these asshole physicists keep talking about this. It sucks. Gravity sucks. Gravity sucks. No, 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 no. We'll just make... Sometimes it's gravity, sometimes it's not, stuff that sits out there, and every now and then it doesn't suck, it pushes. Okay, fine.
In his theory of gravity, gravity was always attractive. There just was no other option.
There was no other option because we just don't consider options, because options are for assholes. They're almost the same letter, A, and option. Option sounds like it starts with an A almost. Fuck.
But it turned out that this more complicated theory of general relativity...
Yeah, there's more complicated bullshit of pretending light is being bent because elevators move. Yeah, sorry. No sail. Because your pencil draws a crooked line, it means the light actually bent. No, the elevator actually moved. But let's ignore that.
Actually allows for the possibility of a repulsive form of gravity.
A repulsive form of gravity. There we go. See, I mean, I like the idea that they're getting to this. But did you see where they put the repulsion? Inside. So it wasn't like they said repulsion in the sense of push. They put the repulsion inside and pushed. So now there's gravity pulling and pushing from the same inside. So now it's vibrating gravity. Yeah, it's vibrating.
Yes, in very specific circumstances, gravity can provide a push, not...
Yeah, yeah, when I want it to. Hey, gravity baby. Yeah, do that push-pull thing. Yeah, sometimes it's fun, I'll admit, but it's not reality.
A pull. It comes from something called the Foss vacuum.
There we go, the Foss vacuum, the Foss. Invented by Dr. Foss.
Of matter in the early universe that allows expansion of space while the mass density stays constant.
Right, so it allows everything to go, every single little speck of space grows bigger, so everything goes further away from everything else in a perfectly little, everything gets bigger thing, except none of the internal matter gets bigger. So all the space inside the atoms, all this empty space that's supposed to be inside my molecular structure, all that empty space is immune from this condition. And it only affects those things out there, you know, galaxies and such. And that way we can bend the universe. Yeah, see, they're warping the whole universe now. Let's warp. Hey, look, we warp space already. once. Let's do it some more. Let's warp the whole fucking universe.
And that understanding for the mechanism of inflation brought a solution to the horizon problem.
Which wasn't a problem, right? You didn't have a problem with this horizon thing, did you? I didn't. So now we have another problem. The flatness problem. This is where they really, really go off the deep end, right? Flat universe, closed universe, open universe, universe that smells like tuna.
Second problem was called the flatness problem. Why is the universe so flat? And what do I mean by flat? Well, the curvature of the universe is defined by the mass density of space, or the amount of...
The mass density. So they're saying that somehow this has something to do with being curved, right? This is how much stuff there is somehow something to do with being curved. So if I gain 10 pounds, somehow my matter is all curvy.
Of energy and mass per volume. If there is a lot of matter, the universe is closed and collapses back in on itself. If there's not...
Right, so that's just saying if there's a lot of matter, there's a lot of, and this gravity stays the same, which I would argue is, that's where they fuck it up, is they don't understand conservation. Gravity's coming from space-time, right? If you make less space-time inside the matter, then there's more space-time outside the matter. So it's always conservative.
Much matter, the universe is open and it will expand forever. If, however, the universe is in perfect balance and the density is exactly critical density, the universe will be flat and it will...
Right. So somehow they've done all this. They've kept the universe somehow flat, where somehow they've calculated that there's enough mass in the universe for nothing to ever gain escape velocity, so to speak. But we sort of know that the universe has to be leaking mass because it's leaking photons. It's leaking radiation. We know it's leaking it. Yet somehow they say they know it's conservational. That somehow that leaking is not in any way important. It could leak forever and it'll all stay together. Because leaking doesn't matter. Something like that. I mean, it's sort of a useless thing to say, I suppose, to me anyway. And especially it's useless when they're adding things like dark energy and dark matter. So is it does it remain flat even though you've added dark energy and dark matter?
Continue to expand forever, but at an increasingly slower rate. So it will eventually stop, but when time reaches infinity.
I think that sounds like a mathematical convenience, doesn't it? It won't stop until it reaches infinity. Well, I guess it's one of those unsustainable curves. As long as you don't hit zero, you can keep doing the math forever. But whatever, it just doesn't matter. I mean, it's still a canard. It's still just. Well, I mean, there's nothing here. There's nothing to base this on, but assumptions.
Mass density we've measured so far appears to be exactly critical. Why is that? In fact...
Well, again, I just totally dispute that argument because I think they've found mass density problems that they can't resolve already. What's holding some stuff together. They're saying there doesn't appear to be enough gravity in some galaxies for the galaxy to stay together. So you synthesize it. So again, what numbers are you using when you calculate this whole mass of the universe bullshit and say, well, based on the space and the amount of mass, you have some equation that says nothing could ever escape. But again, that's not how the universe is made. The universe isn't one blob of shit and a moon and they're circulating each other or something and you can say nothing escapes. We already know stuff must be escaping because the photons are going that way. And they're not going to come back this way.
If it had started even slightly open or closed, it would have been pushed even further away from critical density over time by the expansion of the universe. Just like the longer an arrow has to travel toward a target, the straighter you had to have initially shot.
Well, yeah, if any of that was happening to the universe. So again, if you just make assumptions that there's some sort of... well, we know there's leakage, so I'm just saying that in that sense, if you just drew this thing as a representation of the fact that the universe is going to run out of matter, well, that does seem sort of obvious.
The arrow.
I mean, I would argue that as it runs out of matter, what it's also doing is the gravity is getting weaker. So, at the same time as the matter's getting lesser, the gravity's getting weaker, so they can get away with it for a while. But eventually, everything is just going to fall apart.
But we're so close to hitting a bullseye. We're so close to critical density. Why? Inflation forces the universe toward critical density. How?
In the conventional Big Bang theory, the universe gets larger, but as it gets larger, it gets much, much less dense. During inflation, the universe is getting larger and larger, and hence flatter and flatter, at a fixed mass density.
General...
Right, well that doesn't make any sense, because I mean, I'll just play this again. At a fixed mass density, so that would mean you have to be making more matter.
But as it gets larger, it gets much, much less dense. During inflation, the universe is getting larger and larger, and hence flatter and flatter, at a fixed mass density.
Well, you see all this fixed mass density stuff's flying into the universe. What sense does that make? The universe can't be getting more massive. So what is that? What is that? That's not a very good explanation. It's a stupid explanation. The universe now has more stuff in it than it had 1 billion years ago, or 10 billion years ago, or 20 billion years ago.
General relativity implies a direct relationship between the mass density and the geometry of space, or the
well, again, so they're comparing gravity, okay, caused by what are round bodies, and then they're metaphoring the entire universe as if it was an Earth and a moon. And then saying, what's the relationship between the Earth and the moon? Or an Earth and an Earth. They're basically just taking the entire universe and turning it into a simple model of a gravitational interaction and saying, will the gravitational interaction stay in orbit? Or will it fly out of orbit? Or will it crash into the sun? I don't think that's a rational thing to do. The universe isn't a sun revolving around a sun.
Planets. So as space expands, the geometry gets flatter. Imagine space like the surface of a...
Right, so this is exactly what they've done. They're basically playing that same old Einstein game. Let's just bend the universe and create an artificial place to hide energy, and then we can keep the whole thing together.
Balloon. As you blow the balloon up, the surface gets flatter and flatter. Space...
Well, and I didn't see when you blew that balloon up, I didn't see that it was really big on one side and really small on the other side, or wrinkled on one side, not wrinkled on the other side. So where was your problem with your mixing thing? Where did the two sides of the balloon have to mix?
Space does this in 3 dimensions, and as space gets flatter, we go back to our relationship between geometry and mass density, and we find that the density is pushed toward critical density. In fact, it's
pushed toward critical density. Let's see, I don't know what that, I guess that's the falling to yourself thing. But again, I don't think there's any evidence that the universe is doing that. The universe is looking pretty weak.
Pushed very quickly toward critical density, since the expansion of space during inflation is exponential, which explains why we're so...
Right, so the expansion of space. So they keep just telling us that's the truth. Okay, space expands, accept it. I'm telling you, that's the way. We have a ton of evidence somewhere. So with that one slit experiment evidence, it's all, it's in the Tesla vault.
Close to critical mass density. And boom! Flatness problem solved. So you may be wondering if inflation theory was...
I'm wondering whether like it's 1 in 1,000 people who know what you just said. Boom! Booyah! Yeah, I don't think so.
So revolutionary and imaginative? Why haven't we heard more about it? Well, inflation is still a hot topic of debate. As we discussed, it solves many of the problems of conventional Big Bang theory, and is widely accepted throughout the scientific community, but like all good theories, it has to make more predictions.
Right, of all good theories, like all good theories. It's a good theory, trust me, it's a good theory. It won't rape your children.
Which we then observe. We're hoping for more observations that support inflationary theory, or whatever...
We're hoping for that. Obviously, you're fucking humping it hard.
Theory that might improve upon it. That's what we're working toward. Thanks.
Yeah, I don't know what you people are working towards. You all sound like religious kooks to me. Thanks.
For watching.
Yeah, okay. It's just part of some network now. PBS bought her off. But anyway, let's do this one. This one ought to be funny. sorry, the length of this video is preposterous. But it's science, damn it! It's important.
When I first landed here, I said to
myself, why am I a moon person? It's kind of a silly thing to do, is walk on a moon. What am I doing that for?
Dark matter. Sounds pretty dramatic, huh?
Right,
Like some
right,
sinister goo under control of the Sith Lords. Maybe that's what dark matter is.
Exactly. Maybe it's just made up crap because you kooks can't make any of your mumbo jumbo make any goddamn fucking sense.
So, you might not think so if I told you we only call it dark matter because it doesn't interact with light. Yep, it doesn't.
Right. It doesn't interact with light. So that what they're basically saying, it doesn't have electrons, right? Because electrons are what interacts with light. So we can't reflect light off of it. So we can never see it scatter light or do anything to light. So we can shoot, no matter what we shoot through it, nothing will ever bounce off of it or be refracted by it. But by gravitational lensing rules, oh, it's all okay because it's got gravity. So it's not like any matter we know. It's new matter. It's not dark matter, right? It's not only just dark. It's not really made out of matter. It's a new element called invisible. Or, yes, come up with some kind of transparente. It's made out of transparente. Yeah. So we'll never be able to see it because it's transparent. But it makes gravity, goddammit. A lot of it. A ton of it. But no electrons to get in the way. No protons, no neutrons, none of the elements of matter. Fuck that. Who needs elements of matter? That's a silly thing to need.
Reflect light, it doesn't absorb light, it doesn't interact with electromagnetic radiation or light at all. That's why we call it dark. I know, that's a...
Yeah, I know. That's preposterously silly. We did this whole thing. Einstein said E equals mc squared and all that kind of stuff. But yeah, fuck that shit. Let's do this instead.
Pretty physicsy statement, not quite as sci-fi. But I promise you, there are still so many mysteries surrounding dark matter. And we're going to talk about what dark...
Oh, cripes. I mean, really, they're just saying it exists. They've declared it exists. Why? Because they can't make their idiotic lensing theory work without it. They can't bend light unless they invent the invisible, non-light reflecting matter to cause the gravity, to cause the lensing. And this is called science.
Matter might be, how we know it's there, how we know what it's not, and why we might be wrong about all of this in the end.
Yeah, well then why are you talking like it exists then, bitch?
So dark energy makes up 69% of the energy density in the universe.
Oh shit. No. You were supposed to talk about dark matter. Don't do this. Don't do the dark energy thing, right? Because that's outside the galaxy. Why did you do that? Alright, so we have 69% dark energy. So that is energy not made of anything we commonly understand to be energy. Transparent photons.
And 26% is dark matter, and about 5% is baryonic matter, or...
Right, so now they've called regular matter baryonic matter because it has neutrons and protons and is mattery. But dark matter is 40 times more of that. Yeah. That's the real universe. Invisible.
Or ordinary matter. Wait, what? Only 5%? That's crazy.
No, it's silly. It's crazy, but it's also incredibly fucking silly.
5%, the baryonic matter, that includes me, you, our Earth, the solar system, all...
Well, look, the truth is, it's actually the truth, right? If they understood what gravity is, well, then they would understand that gravity is a lot more of it. The little quanta making up gravity is a lot more of that than this little bitsy shitty matter shit. Okay? You don't see gravity until two things do the gravity thing. You only see the gravity when there's an imbalance and two pieces of matter are pushed together by it. Because gravity only affects matter. So, yeah, if they understood the reality, then they'd understand that you don't call gravity matter. is we understand the difference between matter and gravity. One thing is caught in traps. The other thing is free. It's free to roam the universe, the gravity.
All of the stars, the Milky Way galaxy, all of the galaxies, everything we can see. It's all only 5% of the energy in the universe.
Right. So I would argue that that's right. So let's use that. I'll use their number, 5%. And I'll say that, yes, most of the quanta is in the form of gravity. And only 5% of the universe is in the form of matter, hard things. Things caught in orbits. Quanta, trapped.
So then how do we know that? And how do we know that 26% of the rest of the stuff in the universe is dark matter? That's the...
See, if they were talking about this as if they were describing some kind of real thing, then I'd go along and I'd say, yeah, you're just basically explaining exactly what I'm arguing for. But obviously they're only doing it because they're contrived it so they can make the lensing work. So their purpose in creating it is wrong. So I can't really say, oh, they're getting there, because their reason for creating it is completely unrelated to its reality.
First question I had. If we can't see dark matter because it doesn't interact with light, so how would we see it since we only see things with light? How do we know it's there in the first place? Well, how do we...
Well, right. So you shouldn't say light, because we obviously see things with any kind of electromagnetic spectrum item. Something, all matter, will react to some form of electromagnetic radiation, because you really can't hide the electrons from it. You just can't.
Never know something's there that we can't see. What about wind? You can't see the air moving, but you can see its effects on other things. Such was the case with dark matter. All the way back in 1933, this dude named Fritz Zwicky was studying a cluster of galaxies called the Coma Cluster. See, galaxies are like mean girls and are often found...
So, 1933, he was studying galaxies. And, you know, a lot of people keep talking like nobody knew in 1933 that they even existed. So, on one hand, Lawrence Krauss is saying, nobody knew a galaxy existed. And then on the other hand, she's saying 1933, some guy was routinely studying them. Well, whatever. Seems a contradiction.
Clusters. When galaxies orbit one another, they're often playing this game. The faster they're going, the stronger they need to hold on to one another.
Yeah, it's the wrong way to say it also, right? I mean, they don't hold on to each other. They are pushed into each other. So again, this is all dependent on their notion of what causes things to interact with each other in space or in atoms. And they keep thinking things have to pull into each other. So that's why they have to create this, where's the source of the pull?
And what's the force holding orbiting galaxies together? Gravity. The faster they go, the more gravitational attraction they need to hold them together. And we know more gravity...
They need, again, this needing thing. You know, the more there has to be.
It only comes from adding more mass. Well, no problem.
See, no, it doesn't just come from adding mass. So that's where you got it wrong. It comes from acceleration. Your acceleration towards the Earth causes gravity in the Earth. You creating acceleration in the structure of the Earth's mechanism, disrupting it, accelerating parts of it. By accelerating parts of it, it creates the gravity that pulls you down.
Look at how fast the galaxies are orbiting, and you calculate how much mass is needed for the gravitational force to hold them together, and voila! You find that there is mass missing. Zwicky saw the galaxy...
See, yes, there's mass missing. See, that's it, right? Didn't I say that before? They're saying this thing is happening, and it's closed, and it's even, and yet, oh no, we can't find enough gravity to explain why those two things can possibly stay close to each other, because they're not heavy enough.
He's moving faster than the gravity of the mass he could see could hold them together. This was the first hint that there might be something out there he couldn't see. He called it dark matter. If you're...
Right, and he could have called it a black hole. He could have called it almost anything.
Thinking, that's it, I could come up with a million ways to explain what Zwicky saw. Well, that wasn't the end. The next evidence for dark matter comes from a totally different but crazy phenomenon. Check this out. When you're...
Well, understand that the dark matter somehow has to be between the two things orbiting each other. So let's just understand that, right? Let's understand it has to be between them and somehow not outside them for this to work. So it has to exist selectively.
looking at a star, the light from the star is usually coming straight at you. But when you place a giant object like a galaxy or a cluster of galaxies in between you, then the light going this way is bent around. Yeah, the gravity from giant objects bends light. It's
Right. Okay. So again, this is science. All right. So this is like the most serious physics. The subject that's supposed to be above them all. Man, this is supposed to be the serious shit. You know, we have complex equations and we're really smart and blah blah blah. And we understand all kinds of fancy stuff. And this is how they illustrate it. Right. So Einstein's, again, I'll just go back to Einstein. Einstein would argue this only happens in the strongest gravity you can make. Is where light gets bent. Light is going so fast that you need really, really strong gravity to make it move. Just as you can understand that you need really strong wind. If I shoot a bullet, a high velocity projectile, I need a really strong wind if I'm going to push that bullet in a different direction, right? But obviously I'm arguing you can't push bullets. You can't push light. Light's gravity with a frequency doesn't get pushed. It hits electrons and bends in terms of it goes into atomic gravity. Okay, it has to go into an electron's gravity. It's really its magnetic field and leave a new direction. It can't do it any other way. It has to interact with quanta that are trapped in matter. This doesn't fucking happen.
almost as if there were a giant lens in between you and the star. Shockingly, we call this gravitational lensing. So depends.
Right, you call it that, you say it exists, and your evidence for it is, well, when we see it, it doesn't make any sense, so we throw a bunch of dark matter in so then the lens can work. So we contrive an excuse.
Depending on how much the light is bending, we can estimate the size of the galaxy because, again, more mass, more gravitational pull on the light. So
again, just understand that picture of a galaxy, right? You understand there's a bunch of empty spaces in galaxies. Galaxies aren't solid matter, and so their gravity is dissipated through all of those separations. Density is critically important to the creation of gravity. You have to have condensed matter. If you have vacuous matter, you have weak gravity, not strong gravity. If you have matter, if you take the sun and make it its size as big as the Earth's orbit, then its gravity is only going to be the Earth's gravity. It's reduced to that.
we look at the galaxy and we calculate all the matter we can see, and they don't add up. There's missing mass again. What do you think it might be? Now,
right. It might mean that your assumptions are wrong. It might mean that, frankly, gravity it might be different in different parts of space, but that's another explanation. The field doesn't have to be perfectly even. Depending on how much activity is in the field, the gravity is going to change. But anyway, let's hear that. Let's play the videotape.
there's even more evidence for dark matter, and it has to do with how stars are moving around the galaxy. But I'll let you think through that one. Okay, I'll give you a hint. They're moving around the galaxy faster than they should be.
Again, meaning they have too much velocity to be held in place. But again, this whole argument is dependent on them being able to weigh the mass in the center of the gravity. So all I have to do is put a black hole in the center of the gravity, and I can create mass that can make some explanation. But really, the outskirts of the gravity are the outskirts of the galaxies are a little hard to explain in the sense that it's pretty far from anything. But that's where all that stuff gets connected to each other. That's why I think galaxy has the swirl, is because the suns are not connected to the central gravity. They're connected to the suns associated with them. So their gravity their velocity is dependent on the suns they're connected to, so to speak. That gravity's pulling them.
Many people have speculated dark matter is just a bunch of machos. No, not nachos. Machos. Massive compact halo objects. These
Massive compact halo objects. So, massive compact halo objects. Well, let's make something out of that. Let's take a look at this thing. Yeah, not too bad. Alright, I like it. Yeah, it's pretty good.
compact halo objects. These are things like brown dwarfs, white dwarfs, even black holes. Things.
Well, why are you calling? Look, black matter, dark matter can't be matter. You just said how it can't have electrons because it doesn't interact with light. I mean, these things interact with light, so why are you doing that?
That have very low luminosity, or light emanating from them, but are small and dense. Well, some of the missing mass might be these machos, but
So they're just basically saying that the galaxy might have a bunch of planets in it, you know, or other bodies, comets, whatever you, asteroids, it doesn't matter. It might have a lot of matter in the interior that we're not seeing, and that matter in the interior is creating enough gravity to, you know, fix the velocity problem on the outside. Yeah.
Logical models of the early universe have shown that we shouldn't see more than this 5% level of baryonic matter, which happens to be the exact number.
Well, again, I don't know this. That just seems like a completely erroneous piece of evidence. You're saying the 5% number was made up from a whole different strangled presumptions. So that isn't like something, it's obligated to match your 5% number that we made up before. That piece of evidence doesn't really match as anything. Well, obviously the lensing evidence didn't match anything either. None of this is evidence of anything
that we measure. So then couldn't dark matter just be a bunch of dark dust and gas? Well, same argument. That's all baryonic matter as well. It can't...
Right, it's baryonic, which means it'll reflect light. But no, what it'll also do is its mass density ratio is not going to be sufficient either.
Account for all the missing matter. So again, what is dark matter? Well, the leading theory is dark matter is likely a WIMP. Yes, we have our machos and our WIMPs. Somebody has a strength complex. A WIMP is a weakly interacting massive particle.
Yeah, weakly interacting massive particle. So it's just very convenient. It has gravity, it doesn't have electrons, it's nuke supermatter, it's invisibodo, it's, why don't you just call it something preposterously silly? Why don't you just call it the Jesus particle, for fuck's sake? It's Jehovah particles. Isn't this just a religion? Aren't you just making this crap up?
I'm just going to tell you what it is. I'm going to leave you with a few questions. What do you think WIMPs interact weakly with? And
other matter. Yeah, but they just make gravity. Thank you.
Why do you think they might have to be massive?
Because you said we need 40 times more mass to account for what we presume to be the lensing. So we need 40 times more mass, so they have to be massive, don't they? Because we got to make them small enough not to see, yet big enough to create gravity. A lot of it. Zillions of tons of it.
These WIMPs couldn't interact with the electromagnetic force, or light, as far as we can tell. So scientists have...
Again, she says electromagnetic force and then calls it light. And it's like, you know, that's just a little bit slimy, right? Because nobody thinks of radio waves as light. So, you know, that doesn't really work. You should just say photons or something. But then you don't like that word probably because it's not wavy enough.
Set up detectors deep underground, hoping that a dark matter particle, a WIMP, will bump into a particle in the detector, although infrequently, and we'll get a signal. If dark matter...
Yeah, well, I'm sure that's going to happen. I'm just sure that's the WIMPs are going to totally cooperate.
Matter doesn't interact with regular matter at all, besides through the gravitational pull that we've seen, then we have no chance of directly detecting it.
Yes, there's no chance of seeing it if it doesn't interact with anything. But frankly, why would it interact? If it doesn't have electrons, how can it interact with anything? And where would it get its velocity from anyway? How could it ever get here? Well, I suppose that's... I mean, I suppose you could just... Yeah, it just gets pushed here by some explosion. So I guess from a supernova or something. It's still silly. Why would it have to even get here? Why isn't there already dark matter just floating about?
For now, we can only hope it does. Well, I hope this gives you a sense of what dark matter might be, what it might not be.
I just don't even understand. How are you going to know that it was dark matter that hit the matter? I mean, how are you going to know that? I mean, you're just going to basically say, look, something hit the matter, right? Because the matter moved. That's what you're going to basically do. You're going to say, we know that the matter is not moving in this thing, and so anything that moves in here has to move because something hit it. And you're just going to say, well, anything that we couldn't see, anything that's invisible to our detector, we'll just call that dark matter that caused this interaction. Is that it? I think that's it.
What it is, what it's not. But remember, science is an ever-growing and changing...
No, it isn't. Science has just turned into absolute bullshit. There's some sort of rules about, like, again, extraordinary claims, extraordinary evidence. Extraordinary claims, some fucking rational evidence. I mean, I'm really not asking for that much. I'm just asking, like, for some evidence that isn't completely, I just made that up. I mean, the evidence should be something more than, I just made it up. I just invented a new element. There's nothing extraordinary about that. Yeah, of course, there's new elements all the time. We can make as many as we want. And yes, they cause gravity, but don't cause gravity. They cause it where we want them to, but they don't cause it outside of the things we want to have gravity inside of. It all sounds just so fucking convenient. This is engineered solutions. There's nothing wrong with an engineered solution, but there's some they're cheats. The engineering has been rigged.
Field of knowledge, and because dark matter is so new and unknown, we might yet prove ourselves wrong on all of these.
Yeah, well, you won't prove anything because you didn't prove this in the first place. So there's no point in worrying about the proving part because you don't bother with that beyond reasonable doubt standard. You don't bother with anything that has to do anything to do with reason in a sense. So what's the point of talking about proof? Proof in what way? It's always got to be based on some kind of rational standard of evidence. You have to have evidence to weigh. You weigh the evidence. That's the nature of proof. Well, you're saying this is strong evidence. What kind of evidence is this? We made up a fake element, God, and said he made humans assholes, and that's why humans are assholes. Well, it's a viable theory then, isn't it? If we're allowed to just make shit up, why can't I just make up a God that always existed and he made humans to be assholes? There we go. That explains why humans are assholes. I mean, this is just, this is shit. Fuck.
Hypotheses. But for now, we're left with the evidence. And it points to dark matter.
It does, yeah, right. The completely all made up evidence. I mean, completely made up. These are scientists. You have to tell the scientists. Subscribe, scientist people. Visit me on Twitter, scientist people. I need to tell you to do these things because you understand dark matter, but you don't understand how to subscribe. It's complicated. Subscribing is a lot more complicated than dark matter, so I need to explain it to you. Fuck. Donovan? Her name's Donovan? Ooh, I just pointed to her. Yeah, it's just something my mouse tends to do that. Just goes to... Jeez, rude little fucker. So anyway, that was I didn't do it. The mouse did it. Anyway, till next time. Shit.